In this video, I will be taking you through an AQA GCSE Combined Science Chemistry Higher Paper 1. And the aim of this video is to take you through it in 25 to 30 minutes to make your revision much more efficient. Now, this is a fast-paced video, so please pause it where you need to and ask me any questions down in the comments. So without wasting any more time, let's get straight into question 1. So question number 1, copper is a useful metal. Figure 1 shows the mass of copper produced between 1900 and 2010. Give 2 conclusions that can be made from figure 1. So a first basic observation we can make is that the mass of copper produced increased. And staying on the idea of the mass of copper produced increasing, we can say that from the year 1925 or 1930, there was a huge spike in the amount produced. And there are multiple other things you could say, so any ideas let me know down below. Other people might find it useful. On to the next part of the question. Mixtures of copper and zinc are heated to produce alloys. Figure 2 represents the structures of pure copper and of an alloy of copper and zinc. So as you can see, pure copper is very uniform and all the atoms are the same size and shape, whereas having the zinc in there makes the structure a bit more irregular because the zinc atoms are different sizes and different shapes. So explain why the alloy of copper and zinc is harder than pure copper. So as I said, a big part of this is because the atoms are different sizes. And because of this, the layers of atoms cannot slide over each other. And it also distorts the structure of the whole combination of atoms. And that is all you need for 3 marks. Again, if you haven't seen my previous 2 videos, I mention a lot about how when you have an explain question, you need to make that statement and back it up with some reasons. And this is exactly what I've done here to get that 3 marks. Question 1.3. A 5.25 gram sample of an alloy of copper and zinc contains 13.5% zinc by mass. Calculate the mass of copper in the 5.25 gram sample. So 100% of the sample is 5.25 grams. What we need to work out is what is 13.5%. And if the zinc is 13.5%, we can do 100% take away 13.5%, which is going to give us 86.5%. And then that is going to be the mass of the copper. So we need to work out 86.5% of 5.25. So you can put that in your calculator simply by putting 0.865 times 5.25, and that will give you your final answer. And to 3 significant figures, that would be 4.54 grams. On to question 2. A student prepared copper sulfate by reacting an acid with excess copper carbonate. Figure 3 shows the first 2 stages in the preparation of copper sulfate. We have stage 1 and stage 2. What is the formula of the acid used to prepare copper sulfate? Now, because of the name of the salt in copper sulfate, that indicates that it's going to be sulfuric acid, and sulfuric acid is H2SO4. So that will be your final answer to get the 1 mark there. 2.2. Why is excess copper carbonate used in stage 1? This is simply to make sure that all of the acid is used in the reaction, because if there wasn't that excess, you may run out of the copper carbonate before the acid, therefore there'd be acid left over. 2.3. Beaker N contained copper sulfate solution. Describe how the student could produce copper sulfate crystals from the copper sulfate solution in beaker N. So this is basically testing your knowledge of crystallization, which would have been one of your required practicals. And because this is 2 marks, it's going to be a fairly simple process. All we do is gently heat the solution, and this just evaporates off some of that excess liquid. And then if we leave it to cool gently, it will form crystals, specifically copper sulfate crystals in this case. And that will be your final answer to get 2 marks. A student investigated the thermal decomposition of copper carbonate. Copper carbonate decomposes to form 2 products. So here we have figure 4 where we have a test tube with the copper carbonate in, which is being heated up by a Bunsen burner. And there is the method. And then we also have some results. So we will come back to this. We'll have a look at the question first. Plot the data from table 1 on figure 5. So all we're going to be doing is converting these to coordinates on the grid on the other page. So I will go ahead and do that now and show you the final result. So here are the 5 points plotted, and now we can draw a line of best fit. So because this forms a straight line, we can make that line of best fit straight as well. And it will look something like this. Why does the mass of the contents of the test tube decrease in mass when copper carbonate is thermally decomposed? And if we pop back to figure 4 on the previous page, you can see that there is nothing stopping the end of the test tube, allowing gases escaping. So the reason for the mass decrease is because when the copper carbonate is being heated or thermally decomposed, the gas that is being produced escapes, therefore there is a decrease. Question number 3. Table 2 shows diagrams which represent the structures of two substances. So we have sodium chloride and oxygen. Compare the structure and bonding of sodium chloride and oxygen. So 6 marks, so we can split this into 2 and do 3 marks on each. So first of all, if we just explain the description of what sodium chloride is, it is a strong ionic structure. If we do the same for oxygen, we can say that oxygen is simply a molecule made up of 2 of the same type of atom. Next, it's good to talk about the similarities and differences between them because it asks us to compare them. So we can say that both of them have strong bonds. And also because they're incomplete structures, they will all have full outer shells of electrons. Now on the differences, as we've briefly mentioned already, the sodium chloride is a molecule because it's made up of multiple different elements, whereas the oxygen is simply an element because all the atoms are exactly the same. Continuing on with the differences, we can say that oxygen is very small because it's a molecule, and the sodium chloride structure is what is known as giant in the microscopic world. And the final thing we haven't really touched on is the difference between the ionic bonding that's going on and the covalent bonding that is happening in the molecular structure of the oxygen. In the ionic structure, the electrons are being transferred between the sodium and the chlorine atoms, which is what causes an ionic bond. And a covalent bond is where the electrons are shared between the two oxygen atoms. So that is a key difference, and it will also get us the final marks that we need because it tells us to compare the structure and the bonding. So I will write that up now so that you can see the final answer and what 6 marks would look like on this question. And that is your final answer. Please feel free to pause it and make some notes because learning how to structure a 6-mark question is going to be really handy and knowing exactly all the different things to write about. Question number 4. Nitric acid, which we're told is HNO3, is a strong acid. What is meant by a strong acid? Now, the textbook definition of what a strong acid is it is something that is completely dissolved when put into an aqueous solution or basically water. So that is exactly what we're going to write here. 4.2. Nitric acid is used as a dilute aqueous solution. What is meant by dilute aqueous solution? When you dilute something, it basically just means that you lower the concentration of it by putting it typically in water. So this is just going to be a low concentration of nitric acid in water. 4.3. 10 cubic centimeters of nitric acid solution has a pH of 1. Water is added to the nitric acid solution to change the pH to 3. How does the hydrogen ion concentrate change? Now, the way the pH scale works is it works on a base 10. So if a pH goes from 1 to 2, because that is at the acidic end of the pH scale, so you can imagine if you've got your pH scale here, you've got 1, 2, 3, 4, and so on. Every time you go up a number, because 1 is the strongest pH in terms of acidity, if you go from a 1 to a 2, you're decreasing it by a factor of 10. So if you go from a 1 to a 3, that's going to be 10, and then 10 again. So that's going to decrease by a factor of 100. You will have to be careful how they ask this in the future, because hydrogen ions apply only to an acid, whereas you've got hydroxide on the alkaline side of it. 4.4. Write the ionic equation for the reaction between an acid and an alkali. So an acid, H+, and an alkali, OH-, is a neutralization reaction that returns you with water. And that is your final answer. The equation shows the reaction between magnesium carbonate and nitric acid. So there is your formula. What is the ratio of number of moles of magnesium carbonate to the number of moles of nitric acid in the reaction? So the magnesium carbonate is MgCO3, and the nitric acid, because this is the reaction of the two things, the nitric acid will be this one here. So because by looking at the big numbers in the front, the MgCO3 is 1 and the nitric acid is 2. So it's going to be 1 to 2. And that's going to be your final answer. 4.6. A student mixed some magnesium carbonate with excess nitric acid. The student then added 2 drops of universal indicator to the solution. What colour was the solution after the addition of the universal indicator? Now, because we were told at the start of this question that nitric acid is a strong acid, adding 2 drops of that would have lowered the pH, and when you lower the pH, you put it more towards the acidic scale, and that means that when you add the universal indicator, it will become red. So that will be your final answer here. On to the next one. A student investigated the temperature change when different masses of magnesium carbonate were reacted with excess nitric acid. So here we have our experiment and the method. Pause that and read that if you want to, but we will come back to it. Give 2 improvements to the method to produce more accurate results. Do not refer to improvements to the apparatus in your answer. So a typical one when it comes to improving a method is do repeat experiments of the same thing. So for example, you could have 3 of these going on at once, and a better way of saying that is for every mass of the magnesium carbonate, you could take, say, 3 or 5 readings and then find the mean and discard any anomalous results. Because if you only do 1, as I'm sure you've heard a million times, that could completely skew the results if you get some weird reading. So that would be our first one. And step number 2, if we measure the temperature of the solution, that may not necessarily give you the best results. You either want to do it on a specific time frame, so 30 seconds after pouring the nitric acid into the cup to make sure you're consistent between the masses, or make sure that you're always reading the highest recorded temperature, because that temperature might spike and then drop again if you're reading it at different times or you're not reading it quick enough or paying enough attention. So those are the 2 main points that I would say here. Again, if you have any other suggestions, these are normally quite subjective, so let me know down below. And that would be your final answer for 2 marks. Question number 5. Nitrogen reacts with hydrogen to produce ammonia, which is NH3. Complete the dot and cross diagram for an ammonia molecule. Now it gives it away because of the way this is drawn, but this is a covalent structure or an example of covalent bonding. Another way you would know that is because nitrogen and hydrogen are both non-metals, and we know that 2 non-metals are always going to be covalently bonded together. So nitrogen is in group 5, so that has 5 outer shell electrons at the moment. So let's draw those on now. And hydrogen has 1 outer shell electron because it is in group 1. So we can do 3 circles or dots and crosses, which is why they are crosses and dots. And if you look at this now, because they're all sharing the electrons like a covalent bond does, the nitrogen has 8 outer shell electrons, so it's happy, and each of the hydrogens have 2, so everything has a full outer shell, and that is 2 marks. The equation between nitrogen and hydrogen to produce ammonia is N2 plus 3H2 makes 2NH3. Calculate the mass of hydrogen that is needed to produce 25 grams of ammonia. We're told the relative atomic masses of both hydrogen and nitrogen, which is handy. You could cross-check this in the periodic table if you needed to as well. So this is 4 marks, so it will be a little bit complicated. So one equation that we're definitely going to need here is the equation of Mr. Moles with a mass on his head, is how I've always remembered it. And if you haven't seen my individual chemistry videos, I recommend you go and find them, because I will go through all of these equations in depth there. So to work out the relative mass of the ammonia, ammonia is NH3, which is going to be the same as 14, because that's the nitrogen, plus 3 lots of the hydrogen, which gives us 17. And we can label that as the MR. Now we also know that the mass of ammonia that we're interested in is 25 grams. So using our Mr. Moles with a mass on his head equation, we can work out the amount of moles of ammonia that we have in this equation. So the moles are going to be the 25 grams divided by that 17, and you can put that in your calculator, and that is going to give you 1.47 moles. Now our next step, by looking at the equation, we can see that to produce 2 moles of ammonia, we need 3 moles of the hydrogen. So based off the calculation that we've just worked out, if we do 1.47 divided by 2 to work out what it would be for 1 ammonia, and then multiply that by 3 to get the 3 moles for the H2 that we actually need, that will give us the next step in our question. This can also be done just by multiplying it by 3 over 2, and that gives us 2.205 moles of H2 in this case. And then using our Mr. Moles with a mass on his head equation again, we can work out that mass of the H2 is going to be 2.205 multiplied by 2, because the relative mass of the H2 is going to be 2 times 1, which is 2, and that's going to give us 4.41 grams, and that's going to be our final answer. On to the next question. Figure 7 shows the displayed formula equation for the reaction of nitrogen with hydrogen. In the reaction, the energy released forming new bonds is 93 kilojoules per mole greater than the energy needed to break existing bonds. Calculate the bond energy X for their HH single bond. So by looking at this, we can basically just make up our own equation. So the nitrogen triple bond is 945 kilojoules per mole. So that comes from number 1. Then we plus that to number 2. So that is going to be 3 lots of X in this case, because we don't know what that is yet. And that is going to be the left-hand side of the equation. So we can label that LHS. And looking at the right-hand side, we can see that an NH, so a nitrogen-hydrogen single bond, is 391. Over here, at point number 3, we have 3 of those, and then we have 2 moles of that, so effectively 6 bonds in total. So that's going to be 6 times 391, which you can put in a calculator, and that's going to give you 2,346. And then what we're told is the difference between those two numbers is the 93. So we can say that 93 is equal to 2346 minus 945 plus 3x. And then we just solve it like an equation. So we can first of all work out what 2346 minus 945 is. And it's important to keep this right-hand side in a bracket, because if we were to expand that out, it's technically 945 minus 3x. So now we can carry on with this equation. And if we do 2346 minus 945, we put that in the calculator and we get 1401 minus 3x. And then if we take the 3x to the left-hand side and then subtract the 93, we're going to be left with 3x equals 1308. And then divide that by 3, and we get that x is 436 kilojoules per mole. And that is our final answer. Again, you get 5 marks for that. If you understand how to set up and solve a general equation, just like you would have learnt in maths, that is a fairly straightforward 5 marks. So I would recommend putting some time into learning this kind of stuff. 5.4. Energy is released from the reaction to produce ammonia. Figure 8 shows part of the reaction profile for the reaction between nitrogen and hydrogen. We need to complete the profile line, label the energy level of the reactants and the product, and label the overall energy change. If you've revised anything about endo and exothermic reactions, this will be second nature. And because energy is released during the reaction, it is an exothermic reaction because energy exits. The energy on the products at the bottom is going to be lower. So the graph is going to look something like this, where we can label that with a straight line. So here we can say the overall energy change, and then we can label nitrogen and hydrogen in the reactants, and then the ammonia in the products. Just make sure that you've done all 3 of these bullet points here, and you will get your 3 marks. You may also want to add in the activation energy, just for good practice, which is here, and I'll label that with an A, but that is not necessarily asked of you here. Question number 6. In the earth, most metals are found as compounds. Name one metal that is found in the earth as the metal itself. One answer that you could put for this is something like gold. Other ones that are pure metals could be things like platinum or silver. But again, let me know down below if you know of any others. Figure 9 shows a reactivity series. So we go from potassium at the top end to copper at the bottom end. Suggest the most economical method for extracting metal Z from an oxide of metal. Now, you will be given a reactivity series when you do your exam. And as you can see in the reactivity series we're given here, carbon is one of the things that they use to compare it as, and that is one of the methods you can use for metal extraction from its ore. So what we can do is reduction by carbon. And that is your final answer for 6.2. On to the next one. Figure 10 shows the electrolysis cell used to extract aluminium from aluminium oxide. Name substance X shown in figure 10. So typically when working with aluminium oxide, to make the reaction work a bit quicker and more cost effective, there is a solution called cryolite that is used, and it basically has a lower boiling point than aluminium oxide, so it can become that molten state much quicker and using less energy basically. So it's definitely something to be aware of. It is a very specific question within the electrolysis area, so make sure you do know the electrolysis stuff well in order to answer this question. 6.4. Explain what happens to the positive carbon electrodes during the extraction of aluminium from aluminium oxide. So because when you're extracting aluminium from aluminium oxide, the two products you have will be aluminium and oxygen. So at the positive carbon electrodes, that is where the oxygen will be attracted to, because the aluminium ions will be attracted towards the negative carbon electrodes. So first of all, oxygen is produced. As I said, because this oxygen will be negatively charged, it will react with the carbon electrode and this will produce carbon dioxide as a byproduct. Just to be clear, the reason that it produces carbon dioxide is because it's a carbon electrode and you're mixing oxygen with it, which are the two things that are used to make carbon dioxide. And because of this, it's going to be stripping the carbon from that electrode. So over time, it will have to be replaced because it will start to wear away. And that is the 3 points to get you 3 marks. 6.5. The formula of aluminium oxide is Al2O3. Write a half equation for the reaction at the negative electrode in figure 10. So at the negative electrode, that is where you will get the metal ions, which is the aluminium in this case. The ion for aluminium in this case is going to be Al3+, and that is because it is in group 3 on the periodic table. So it needs to lose 3 electrons to become a full element. And in the way of separating that to make it back into aluminium, it will take 3 electrons from the negative electrode to combine with the ion to make it back to normal aluminium. And that is what your final half equation would look like. Question number 7. Halogens are elements in group 7 of the periodic table. Calcium reacts with chlorine to produce calcium chloride. Explain what happens to calcium atoms and to chlorine atoms when calcium reacts with the chlorine to produce this calcium chloride. So to summarise exactly what I'm going to write, this is going to be an ionic bond between the two things. Calcium is in group 2, so each atom involved in the equation is going to lose 2 electrons. And because chlorine is in group 7, that needs to gain 1 electron for every atom that is involved in the reaction. So first of all, let's summarise that. And it is important to note, obviously, because the calcium will be losing 2 electrons, but the chlorine is only gaining 1, you're going to need 2 chlorines for every calcium atom. So that is another point that we need to add. And it is important to add also that the atoms will now become ions. So the calcium will be a Ca2- is how you'd write it. And the chlorine is going to become Cl- because it's gaining 1 electron per atom. And that is an in-depth way to get the 4 marks on this explain question. 7.2. Explain why chlorine is more reactive than bromine. An important analogy that I don't believe is explained massively in schools. Please correct me if I'm wrong. But both of these elements are in group 7. So naturally you would think that they are both as reactive as each other. If you look on the periodic table, chlorine is quite near the top, if not at the top. I can't remember off the top of my head. Bromine is a little bit further down. What this means is because the atomic number of both of those will be different, the chlorine's atomic number, so the number of protons and therefore also electrons, will be much lower compared to the bromine. This means that chlorine has only 1 or 2 or a few outer shells or shells of electrons. The bromine might have 4 or 5. Because it's trying to gain 1 more electron on its outer shell, think of the nucleus of the atom, so the nucleus of the chlorine, is like the source of the gravity, because that is what's keeping the electrons in orbit, technically. So if you're trying to gain an electron, and that outer shell is really close to the nucleus, it's going to be easy because that gravity, or the electrostatic force within the atom, is going to be very strong. Whereas on the bromine side of it, you're having to try and pull that electron in from, say, 5 shells of electron away from the nucleus. So that electrostatic force that we saw in the chlorine is going to be much weaker out in the edge of the bromine atom. Hopefully that makes sense. I'm just going to summarise that in the way that you would get 4 marks. Please take a minute to pause the video and read that properly, because the wording on this is really important to get you that 4 marks. But hopefully that makes sense. On to 7.3. Table 4 shows the boiling points of 4 hydrogen halides. Describe how the boiling points of the hydrogen halides change as the relative formula mass changes. So looking at this, generally, as the relative formula mass increases, the boiling point also increases. And you can work out the relative formula masses by comparing these to the periodic table and working them out that way. However, you'll notice that the HF, the hydrogen fluoride, is much higher, and we would just describe this as an anomaly, really. And there's not really any other way to put it. The rest of them all follow that trend. And that would be the final answer. All you need to get 2 marks. Again, it's a good time to say this, but when you've got 2 marks like this in a described question, you normally need to describe 2 points. Or say the main point of the question they're asking. So the first point is the relationship. As it increases, the other one increases. And you normally need that extra point just to get you that second mark. Question number 8. Carbon nanotubes are cylindrical fullerenes. Figure 11 represents the structure of a carbon nanotube. Describe the arrangement of carbon atoms in the nanotube shown in figure 11. And as you can see, they are simply hexagons. They are hexagonal. Nanotubes are used in electronics. Give one other use of nanotubes. An example I always go to for this is materials, and specifically sports equipment. At kind of a high level, they start to use nanotubes to make things as efficient as possible for whatever sporting activity it is created for. Other examples do include things like nanotechnology, and that is a perfect example that you could use here. 8.3. A nanotube contains 2,380 carbon atoms. Calculate the number of moles of carbon in this nanotube. And we can use the Avogadro constant, which is 6.02 times 10 to the 23 per mole. And that is atoms per mole. So using this, because Avogadro's constant is the number of atoms in 1 mole, we can simply do 2380 divided by 6.02 times 10 to the 23. And it is going to be a very small number, but that will be the amount of moles in 1 nanotube. And that gives us a final answer of 3.95 times 10 to the minus 21 moles. And the final question of the whole paper, explain why carbon nanotubes can conduct electricity. Refer to bonding between the carbon atoms in your answer. So your go-to answer for any question about why something can conduct electricity is because it contains delocalized electrons. So that is going to be your first point always. So that is kind of 2 points in one. They contain delocalized electrons, and those electrons carry current through the nanotube. So that is your first 2 points. Now the reason that they contain delocalized electrons is because each carbon within the nanotube will be covalently bonded 3 different ways. And because of that, the outer shell of a carbon atom has 4 electrons. So if there's only 3 of them covalently bonded, there will always be that 1 free electron per carbon atom. And that is the end of this chemistry paper. Please let me know down below if you found it useful, and any feedback is greatly appreciated. But I really hope that helped, and I will see you in the next video. Thank you very much.